All right, go ahead and get started. Welcome in. Hello, greetings. Happy Wednesday. Another day, another opportunity to work on some math. So, yeah, I hope everybody's doing well. And I'm going to go ahead and get into it. What I'm going to do tonight is I am going to solve another system using matrices. Right now I'm working on a technique called Gauss-Jordan Elimination, and I'm going to show another way of solving. And I'm going to go ahead and start with a 2x2 matrix, or rather, it's not going to be a 2x2. It'll actually be a 2x3. But what I'm going to be doing is I'm going to show another method and not employing the inverse matrix. This is just straightforward, where I'm going to actually augment the coefficient matrix with the constant matrix. And I thought we would go ahead and start off with a 2x2 and maybe work into the 3x3 later on. So I'll go ahead and just get started. I'm going to erase everything. I think everything except for the title, and see how it goes. This is a problem that is I've taken from my linear algebra book class in college many years ago. I took called linear algebra, and it's a whole branch of mathematics dedicated to solving systems of linear equations and applications. So textbook is pretty thick, and I'm just on chapter 1. So yeah, we'll work on matrices until I get bored, or until a student comes and asks me another question. Okay, so I just picked this system out here, and let's go ahead and write it down. It says x minus, and they use subscripts, so we might just use sub to change the variable here. All right, so this is x minus 2y equal -8, and then this one is 2x minus 3y equal -11. All right, so start out kind of simple. 2 equations, 2 unknowns. Let's see if we can get this system. And then what I want to do real quick is just find the solution. So let's go ahead and look the solution up real quick before I work it. This is section 1.1. Number 10A, perfect. This is x equals 2 and y equals 5. So we've got 2, 5 for our solution. Again, remind you that these solutions to systems of equations is an ordered pair, and it's an intersection on the Cartesian coordinate system. So when you graph the system, maybe for fun, we'll graph it, because it's been a while since I've sketched any graphs. First 2 months I did this live stream, like all of my live streams were mainly graphs. Years ago, way back when I was in high school, and I actually started in junior high, I was my favorite subject was art before it was math. So I'm liking incorporating the drawing in the math. That's fun, and it's good for me. It's very satisfying writing it out. All right, so what we're doing is we're going to use Gauss-Jordan elimination, and according to this method, we're going to call a matrix, and we're just going to list the coefficients. We've got 1, -2, 2, -3, And then what we're going to do is we're going to augment this with the constant matrix. And then we're going to use that same process yesterday, elementary row operations. And what we're doing is we're getting this side of our matrices in this thing called reduced echelon form. Reduced echelon form. It's a way of making sure that, we already have a 1 here. It needs to be followed by a 0. So you only have 1 in one row, and this is called the leading one. And so this would be 0 and then 1. So this would be the identity matrix. I'll just write this in here. One, 0, 0, 1. And when you have it in, you found your identity matrix, essentially you put this in reduced echelon form. It's like, I thought I could spell it. I'm pretty sure that's correct. I remember there being a CH in there. All right, so I might end up having to erase this, but that's essentially what we're doing. That's the game. So I want to do a series of elementary row operations consisting of those main 3 rules that we discussed the other day, where 1 is swap. Swap. 2 is multiply. And then 3 is add equations. Add. So swap rows, multiply by scalar, or add rows. And then, so these are your elementary row operations. So let's put that in here. Again, this is just me trying to gain a skill, trying to explain advanced math, which is not, it's not intuitive for me. So I feel like that after I practice for a really long time, maybe I'll be good at it. I don't know, we'll see. So we've got the elementary. All right, so let's go ahead and get started. And so what I want to figure out, I want to do is I want to make this number right here a 0. So I'm going to multiply, let's see what I could do. I also need a 1 here. And I need these 2 to be 0s. So I have to think about it for a minute. Figure out what I want to do. So we could just go ahead and handle that first column. I would have to multiply row 1 by a -2 and then add a row 2. So that's what we'll do. So we'll say 2 row 1 plus row 2, and then we're going to replace row 2. And we'll rewrite the matrices. So rewriting that first matrices, multiplying by 2, -2 rather, and adding. So -2 times 1 is -2 plus 2 is 0. So I need to go ahead and replace that -2, +4, and then 2 times 8 is 16. And then -2 plus 2 is 0. 4 minus 3 is 1. And then 16 minus 11 is 5. All right, so we've already solved that bottom one. What I need is this number right here to be 0 now. So what we're going to do is we're going to multiply row 2 by a -4. And we'll add to row 1. Because when I multiply 0, it's not going to change the value of 0, so it's not going to affect that too much. So let's go ahead and we'll write that in here. Let's say -4 row 2 plus row 1. And then we're going to replace row 1. I'll write that in here. All right, so we're going to say -4 times 0 is 0. -4 times 1 is -4. And -4 times 5 is -20. And then we're going to add to row 1 and replace. So we have 0 minus 2 is -2. -4 plus 4 is 0, which is what we wanted. And then, let's see, and -20 and 16 is going to give me, is that negative? I think it's 16 and yeah, -4. Okay. All right. And that looks weird. It's kind of sprung out, so I'll make it a little condense. 4. And that was 0, -4, or was it -20? So we got -2 times row 1 replace row 2. I'm just making sure I'm doing everything correctly. And I think I'm good. All right. So now all we have to do is we're going to apply that rule 2 and we're going to multiply, because we want this to be 1, so we're going to have to employ the reciprocal. So the reciprocal, the product of a number and its reciprocal is always equal to 1. So I can find the reciprocal of this to make this 1. It's going to be -1/2. And I'm going to multiply row 2 by a -1/4. And so when I do that, just write our new matrix here. I'm used to writing those big matrices. I'll practice this a couple times with a 2x2 and then maybe try a 3x3 if I have time tomorrow. So we've got this -1/2 times -2 is 1. -1/2 times 0 is 0. And then we'll figure out what -1/2 times -4/1 is. So you're just multiplying numerators and denominators. So you got -1 times -4 is 4. And 2 times 1 is 2. 4 divided by 2 is 2. And then we're going to repeat that process with this one right here. So -1/4 times 0 is 0. -1/4 times -4 is 1. And then -1/4 times -20 is, let's see, that's 20 divided by 4, positive, which is 5. All right. So it looks like we have found our solution. So we'll say x equals 2. And then the second row would be the y, so y is going to equal 5. So this is a very simple example of how you would use Gauss-Jordan elimination to solve this system. But again, I only had a couple steps and it took me not very long. It's like maybe 15 minutes. and that was writing on the board and explaining. So this is a very, very useful method for 2x2 systems. However, if you have a graphing feature, you can just plug those in. You can enter both of the equations into either, if it's a program online in the computer, Desmos or whatever, or if you have a graphing calculator, you can just graph them and see visually where that intersection is, and that's going to tell you the solution. Like if I were going to sketch the graph of this by hand, I would have to solve this for y, because this is standard form here. So if I want to spend a little bit more time, I probably could do that and solve this one for y. So we could do that here and graphically look at it. It's been a while since I've graphed anything, but it used to be fun. So just solving this for y, we begin by subtracting x from both sides. That's going to give me negative 2y equals negative x minus 8. And then just dividing off the negative 2 from everything and simplifying. And you're putting it in slope-intercept form this way, and so it makes it really easy to graph a line. So we've got negative 1 over negative 2 is 1/2 x, and then negative 8 divided by 2 is equals 4. So this is telling me y-intercept of 4, and this is the slope form, so it's rise over run. So we'll sketch that one. And to repeat that process with the other one, both of them. So this one, just subtracting 2x from both sides, it's going to give me negative 3y, and that equals negative 2x minus 11, and then dividing off the negative 3 from all three sides, you get y equals, and it's 2/3 x and it's negative 11, it's going to be plus 11/3. So that is real close to 4. That's 3.6, so it's closer to 3.5. So if you wanted to go ahead and sketch, you plug your Cartesian coordinate system and yx, just for fun, we'll sketch these graphs. So the first one, we're going to identify that y-intercept at 4. That is a true point on the graph of that line. And then we're just going to apply that rule, rise over run. So we're rising 1 and running 2. So that's going to put me at, looks like 2,5 right here. And then the other one, this one here, I'm circling. It looks like my y-intercept's 3.5, so this was not even distribution here. So let's see if we can get a little bit more even increments. 1, 2, 3, 4. Looks like it's right at 3.5 here. And then rising 2, running 3. So it's like 1, 3. So 1, 2, and 3, probably right here. So it looks like, and then we got this sort of thing going on. And then, so here would be the solution in there. And that was just an extremely rough sketch of the system. There was an intersection. There we go. Get 2, 1, 2, 3. All right. And I'm probably going to go ahead and call it good there. I know that was an extremely short live stream, but to be honest. I'm just really trying to discipline myself to come and do the math. And yeah, it's been a long day, so I'll probably go ahead and end it there on a good note. And yeah, I hope everyone has an amazing rest of their Wednesday. And I will be back tomorrow. Hopefully I will have something a little bit more prepared. I don't want to get too lazy with my live stream, so I have to, yeah, make sure that I'm giving myself some kind of criticism every day so that I'm growing. But I might just give myself a break today. All right, so if you watched my video, thank you so much. If you need help with your math, please, by any means, come join me at this time. Same place, same time, Monday through Friday, 6 p.m., 7 p.m. Central. And yeah, I enjoy doing all kinds of math. So if it's challenging, then that's good. And if it's easy math and you just need help, I want to be helpful. So hopefully I catch some students. And in the meantime, I'm just going to try to stay busy, sharpening my skills. I better stop rambling there. And I'll go ahead and say bye for now. And I'll see you next time.